Can you comprehend the power that artificial intelligence holds over our lives today? It's not just the stuff of science fiction anymore. AI, as we fondly call it, is here, and it's changing the way we live, work, and even play. But what exactly is AI? In a nutshell, artificial intelligence is the ability of a machine or a computer program to think and learn. It's about building machines that can engage in human-like thought processes such as learning, understanding, reasoning, problem-solving, perception, and language comprehension. Now you might be thinking, okay, that sounds impressive, but do I interact with AI on a daily basis? The answer is a resounding yes. Every time you ask Siri for the weather, or when Netflix suggests a new show based on your viewing habits, or even when you're scrolling through your social media feed and the ads seem eerily tailored to your interests, that's AI working its magic. But the magic of AI doesn't stop at your smartphone. It's revolutionizing industries and fields across the globe. In healthcare, AI is helping doctors diagnose diseases with greater accuracy. In finance, it's being used to detect fraudulent transactions. In the automotive industry, it's powering self-driving cars, and these are just the tip of the iceberg. The potential uses of AI are vast and still largely untapped. AI is indeed a powerful tool, but it's also a tool that requires careful handling. There are ethical considerations and potential pitfalls that need to be addressed as we continue to explore and push the boundaries of what AI can do. Now imagine building your own AI model. Sounds intimidating? Fear not, as we are about to demystify the process. Stay with us as we delve deeper into the world of artificial intelligence, unravel its complexities, and guide you through building a simple AI model from scratch. The journey may be intricate, but the rewards are immense. You're about to embark on an adventure that could well reshape the future. Let's dive in, shall we? The foundation of any AI model lies in its algorithm. Now, what exactly does that mean? In essence, an algorithm is a set of rules or instructions that a machine follows to solve a problem or achieve a goal. It's like a recipe where each step is meticulously laid out to ensure the end result is as intended. In the realm of artificial intelligence, algorithms are the driving force behind a machine's ability to learn, adapt, and make decisions. They form the backbone of every AI model, from simple chatbots to complex self-driving cars. There are several types of algorithms used in AI, each with its unique strengths and applications. For instance, we have supervised learning algorithms, which learn from labeled data to predict outcomes. These are great for tasks like image recognition or spam detection. Then we have unsupervised learning algorithms that identify patterns and relationships in unlabeled data, perfect for market segmentation or anomaly detection. There are also reinforcement learning algorithms, where an AI learns to make decisions by interacting with its environment and receiving rewards or penalties. This is the kind of algorithm you'd use if you were building a chess-playing AI or a self-navigating robot. Choosing the right algorithm is a crucial step in building an AI model. It's like choosing the right tool for the job. You wouldn't use a hammer to screw in a bolt, right? Similarly, the choice of algorithm depends on the problem you're trying to solve, the data you have at hand, and the desired outcome. It's a decision that requires a good understanding of the strengths and limitations of each algorithm, as well as the specifics of the problem at hand. So to recap, an algorithm is the set of instructions that guides an AI's learning process. Different types of algorithms are suited to different types of tasks, and choosing the right one is a critical step in building an effective AI model. With the right algorithm in place, we can then move on to the next step: data collection. Data, the driving force behind any AI model. That's right, without data, we're essentially trying to paint a masterpiece without any paint. So let's dive into the world of data and its crucial role in AI. In the realm of artificial intelligence, data is the raw material. It's the information that the AI uses to learn, to grow, and to make decisions. Think of it as the lifeblood of the AI model. Just as our bodies need blood to function, AI needs data to operate. The more data we feed into our AI model, the more it learns and the better it performs. But not all data is created equal. There are different types of data that we use in AI. There's structured data, which is organized and easy for the AI to understand. This is data like names, dates, and addresses. Then there's unstructured data, which is a bit messier. This includes things like text, images, and videos. While it can be more challenging to process, unstructured data can also provide a wealth of information for our AI model. Now let's talk about how we collect and prepare this data. Data collection can come from a variety of sources, including databases, sensors, social media, and more. The key is to gather a diverse range of data to provide a comprehensive learning experience for the AI. But collecting data is just the first step. Once we've collected the data, we need to prepare it. This involves cleaning the data to remove any errors or inconsistencies, and transforming it into a format that the AI can understand. This process, known as data pre-processing, is a critical stage in building an AI model. It's like preparing ingredients for a recipe. If we don't clean and chop our vegetables, we can't expect to make a delicious meal. In conclusion, data is the foundation of any AI model. It's the raw material that fuels the learning and decision-making abilities of the AI. Without it, our AI model would be like a car without fuel. Once we have our data ready, we can proceed to the crux of the process, training the AI model. Training an AI model is akin to teaching a child. This statement, while simple, holds the essence of what we're about to dive into. The process of training an AI model is one of the most crucial steps in building a robust and effective system. Imagine a newborn, their mind a blank canvas, ready to absorb information and learn. That's your AI model at the start of the training process, a blank slate ready to be imprinted with data. The AI model learns from the data we provide, much like a child learns from the world around them. But what does learning mean in the context of AI? It's all about patterns and making connections. The AI model sifts through the data, identifying patterns and connections, and uses these to make predictions or decisions. This process is iterative. The model keeps refining its understanding as it encounters more data. Think of it as a game of guessing. Initially, the AI model might make a lot of incorrect guesses, but as it goes through more data, it starts to understand the patterns better and its guesses become more accurate. This is the essence of machine learning, a core component of AI. However, it's important to remember that the quality of learning is directly proportional to the quality of the data provided. Garbage in, garbage out, as they say, so it's crucial to feed your AI model with good, relevant data. But how do we know if the training is successful? Well, during the training process, we calculate a value known as the loss. This is essentially a measure of how far off the model's predictions are from the actual values. The goal is to minimize this loss. As the model trains, it adjusts its internal parameters to reduce the loss, thereby improving its accuracy. Training an AI model is not a one-time process. It requires patience and continuous refinement. It's a lot like nurturing a plant, providing it with the right conditions to grow and thrive. After thorough training, it's time for the final step, testing and deployment. Let's move on to see how we put our trained model to the test. Testing and deployment are the final hurdles in the AI model building journey. Imagine you've just pieced together a complex jigsaw puzzle. Now, before you can showcase your masterpiece, you need to ensure all the pieces fit perfectly. That's essentially what testing an AI model is all about. It's about ensuring the model can accurately predict outcomes based on the data it has been trained on. This critical stage is where we identify and fix any potential issues that could hamper the model's performance. Now, there are several methods to test an AI model. The most common is the split test method. This involves dividing our dataset into two distinct parts, a training set and a testing set. The model is trained on the training set and then tested on the testing set. This enables us to assess how well our model performs on unseen data. Another popular method is cross-validation. Here, the dataset is divided into multiple subsets. The model is then trained and tested multiple times, with each subset serving as the testing set at least once. This method offers a more comprehensive evaluation of the model's performance. Once we're satisfied with the model's performance during testing, it's time for deployment. This is the stage where our AI model steps out of the lab and into the real world. Deployment can take various forms depending on the application. For instance, a model designed to predict stock market trends might be integrated into a financial software platform. Alternatively, a model developed to recognize speech patterns could be embedded into a voice-activated device. Regardless of the application, the deployed model continues to learn and adapt. It does so by processing new data and refining its predictions. This ongoing learning process enables the AI model to grow more accurate and reliable over time. With testing and deployment, we complete the journey of building an AI model from scratch. Building an AI model might seem complex, but it's a rewarding journey. As we've seen, the process begins with choosing the right algorithm, a blueprint that guides our model's learning. Next, we've explored the importance of collecting and preparing data, the raw material from which our AI learns. Training the model, the next step, is akin to a sculptor chiseling away at a block of marble, shaping and refining until a form emerges. It's a process of trial and error, of learning and improving. Finally, we've delved into testing and deploying our model. This is the moment of truth, where we see if our creation can stand on its own in the real world. Each of these steps is a thread in the tapestry of AI model building. Individually, they may seem daunting, but together, they create a coherent, manageable process. And that, my friends, is the intriguing world of AI model building. A world where complexity meets creativity and innovation knows no bounds.